Hello everyone, welcome to this lecture video on horizontal curves of highways. I am Porcia, working as Assistant Professor in the Department of Civil Engineering at St. Xavier's Catholic College of Engineering. This video focuses on horizontal curves on highways and its associated components, super elevation, widening edge curves and transition curves. Let's get into the video. Let's start with horizontal curves. The horizontal curves are needed on a road to give a change in direction to the road. When a vehicle moves along a horizontal curve, a force acts towards the outside of the curve horizontally, and this force is known as centrifugal force. And this centrifugal force has the tendency to pull the vehicle towards outside of the curve. We know while a vehicle moves on a road, a frictional force will be developed between the tires and the surface of the pavement. And this frictional resistance developed in the transverse direction helps in counteracting the centrifugal force. And this enables the vehicle to safely move along the road on a horizontal curve and to maintain the stability of the vehicle. This centrifugal force can be denoted as P, and this is equal to WV square by GR, where W is the weight of the vehicle in kilogram, V is the speed of the vehicle in meter per second, G is the acceleration due to gravity, and R is the radius of the horizontal curve. The ratio of this centrifugal force to the weight of the vehicle is known as centrifugal ratio or impact factor. The centrifugal force has two effects on a vehicle while the vehicle traverses along this horizontal curve. One is the tendency to overturn the vehicle outwards out about the outer wheels, and the tendency to skid the vehicle laterally outwards. We know the centrifugal force can pull the vehicle towards outside of the curve. So it has two effects on a vehicle while moving along a horizontal curve. One is to overturn the vehicle outwards, the other is to skid the vehicle laterally outwards. To counteract this two effects of the centrifugal force, to reduce the overturning of the vehicle outwards and to reduce the skidding of the vehicle laterally outwards, the outer edge of the pavement is raised with respect to the inner edge of the pavement. Thus, a transverse slope is provided, and this transverse slope to the pavement surface is known as super elevation, or it can also be called cant or banking. In this picture, we can see the outer edge of the pavement is somewhat raised with respect to the inner edge of the pavement. So thus a transverse slope is provided, and this transverse slope is known as super elevation. And this super elevation can counteract the effects of this centrifugal force on a vehicle. Consider this figure, and this blue rectangle represents the vehicle and this black triangle represents the wheel of the vehicle, and uh, these are the wheels of a single axle, maybe front axle or the rear wheels. Okay. This is wheel A and this is wheel B. We know the weight of the vehicle acts perpendicularly downwards. So W is the weight of the vehicle, it is acting perpendicularly downwards, and the centrifugal force acts horizontally outwards. Okay, so P is the centrifugal force that is acting horizontally outwards. Due to this raising of the outer edge of the pavement, the centrifugal force and the weight of the vehicle both are resolved into their respective components. Okay, so centrifugal force P is resolved into its components P sin theta and P cos theta, and W weight of the vehicle is resolved into its two components W sin theta and W cos theta. Here you can see FA. FA is the frictional force developed between the tires and the surface of the pavement. Here this angle is theta, and it represents the super elevation rate. Super elevation rate small e equal to tan theta. Okay, so raising of the outer edge of the pavement divided by the horizontal width of the pavement gives this super elevation rate. Okay, so super elevation rate is defined as the ratio of height of the outer edge of the pavement with respect to the horizontal width of the pavement, and it is E equal to small e is the super elevation rate, E equal to tan theta, that is equal to capital E divided by B. Capital E is the raising of the outer edge of the pavement with respect to the inner edge, and B is the horizontal width of the pavement. So in this figure, we can see the raising of the outer edge with respect to the inner edge. So the transverse slope is the super elevation, and the centrifugal force acts downwards and the transverse friction acts laterally inwards. So when a vehicle moves on a horizontal curve, three forces acts on the vehicle. One is the centrifugal force and it acts horizontally outwards. Second is the weight of the vehicle and it acts vertically downwards. And the third is the frictional force between the tires and the surface of the pavement. So another formula for the super elevation rate is E plus F equal to V square by GR. Here E is the rate of super elevation, F is the coefficient of lateral friction, V is the design speed of vehicle in meter per second, G is the acceleration due to gravity, and R is the radius of the horizontal curve in meters. And if the speed is given in kilometer per hour, then E plus F equal to capital V square divided by 127 R is the formula. And in this figure, we can see how gradually the super elevation is provided on the horizontal curve. Initially, in the straight portion of the road, the natural camber is provided, and this is the transition curve portion, and here super elevation is provided, introduced gradually on this. And we can see the inner part of the road has the natural camber and the outer half of the road is flattened to provide the super elevation. And here this is the actual circular curve part, and here we can see this is the actual circular curve part, and here we can see the full super elevation. And again comes the transition zone here. Again comes the transition zone.